Hello, I am Mark Colley. Thank you for watching my presentation regarding the paper ORIAS On-the-Fly Object Identification and Action Selection for Highly Automated Vehicles. With the introduction of autonomous vehicles, a lot of advantages seem possible. Higher safety, more leisure time due to non-driving task-related activities, and better traffic flow, amongst others. However, current technology seems not feasible of operating under all circumstances imaginable. For example, the DMV of the state of California received information about over 3,800 disengagements by companies testing automated vehicles. Additionally, 332 autonomous vehicle collision reports have been received. Typically, to solve the issue of bounded driving domains, a takeover is suggested. In this concept, the automated vehicle gives over full control of the vehicle to the manual driver. Numerous works have evaluated many concepts. However, there are negative consequences that are often called post-automation effects. Therefore, some work has evaluated cooperative approaches to overcome system limitations by including the human operator only in a part of the driving task. In this work, we present ORIAS, a system that allows the human passenger to engage with the automated vehicle in case of inadequate object detection. Previous work by Walch et al. Showed that in an overtaking scenario, the cooperation between vehicle and human passenger was preferred to a takeover. Here, the passenger had to click or hold a touchscreen for the automated vehicle to pass the vehicle in front. A more general approach to object identification was presented in the concept of cooperation capture. Here, in case of a failed object detection, failed meaning that a certain detection threshold was not reached, the vehicle would ask the human passenger to identify the object either via speech or via touch display. The touch display used in this preliminary work is shown on the left. The authors found that the shown prediction percentage was unclear, but that the system in general worked well and produced low cognitive load. Their lessons learned included to provide a live preview, separate irrelevant and others as input, activate the microphone automatically, and possibly allow both touch and speech input. These lessons learned were all included in our novel ORIAS concept. On this slide, you can see the user interface design of ORIAS. On the left, there is the possibility to identify objects. On the right, the novel concept of action selection is presented. This is based on the preliminary work by Walch et al., where some participants described actions instead of the object. A shows the live preview with the object location highlighted. B shows the interaction request. C shows the two most probable possibilities determined by the system, plus the irrelevant or ignore button, as well as the possibility to provide other input. D shows the microphone icon, indicating that the system is listening. In this flowchart, you can see the envisioned automation behavior of an automated vehicle equipped with ORIAS. It shows that if an object is not recognized, ORIAS is enabled. Until either a takeover is initiated by the user or an answer is provided and the time budget is still not violated, the vehicle will continue to drive. Otherwise, it will break. If the user fails to provide the input, a handover to the user is initiated. When the user wants to give control back to the automated vehicle, the system checks whether all relevant information is present. If not, the user is asked for it. We implemented a real German city in Scilab 6.5. To avoid confounding factors, we refrained from adding other vehicles and pedestrians. In the middle, you can see the dashboard, which includes arrows indicating where the automated vehicle will drive to. In the center console, you can see the ORIAS user interface. This simulation was used to answer the research question, what effect does the type of interaction request for ORIAS have on number of takeovers, input accuracy, input duration, cognitive load, usability, intuitiveness, trust, control, and perceived safety. We recruited 20 participants, of which 5 were female and 15 were male. They were on average 25.2 years old. As we were interested in the appropriateness of ORIAS in a range of scenarios, we implemented the shown 8 scenarios, and these include a variety of unknown and sprayed-on signposts. In the subfigures with the letter A, you can see the provided potential correct signs for the object identification variant. In the subfigures with the letter B, we show the designed actions for the action selection system. The tick indicates which options we viewed as correct. For example, for the first situation indicating the presence of children, both the drive 30 and the drive 20 km per hour options are valid in our opinion. The same is true for situation 8, in which the vehicle has to drive past a construction site. We found that mental workload was significantly lower for the object identification system. We also found that the object identification system was rated as significantly more usable and that it led to significantly higher trust. Subjective power, as we expected, was significantly higher for the action selection system. We found no significant differences for perceived safety or mutual dependence. We also found no significant differences for the input duration, which was on average between 5.8 and 6.4 seconds. Correctness, without including the option ignore or irrelevant, was significantly higher for object identification. This significance was still prevalent when including possible ignore or irrelevant cases, but the difference became less pronounced. Approximately 10% of the input was done via speech, and only 3 participants took over control, which was, at the beginning of the study, always introduced as a viable option. The post-automation effects of a takeover can be severe, and we believe, therefore, that the cooperative approach is an important step towards using the benefits of automation, such as slow reaction times. Our data suggest that participants preferred ORIAS over a takeover. This is in line with the work of Walch et al., showing that cooperation is preferred. With regard to the question of whether the action selection or the object identification variant is more appropriate, we have to state that it depends. For the simple identification of an object, the object identification variant showed to be superior in terms of mental workload and usability. However, traffic scenarios can become complex and the dependencies of a scene can be high. Additionally, if multiple objects are unknown, identifying them one by one could be time-consuming. Therefore, we argue that for these use cases, the action selection variant is more appropriate. Thank you for your attention.